Hey guys, so in this next part, we're going to look at how to convert between vertex and standard form. So in the left column, we want to convert to vertex form, and just remember what we want it to look like. At the end, we want it to look like y equals a times x minus h squared plus k for vertex form, and I already know what my a is in each of the equations, right? Because a is the same regardless of whether it's standard form or vertex form. So really the only thing I need is I need to figure out what the vertex is, and then I can just plug into the equation. So let's find the vertex. I know that the x-coordinate of the vertex is negative b over 2a. So that's going to give me negative of negative 4, which is 4 over 2 times 1 equals 4 over 2, which is 2. And then plugging in 2 as the input into my f function, we can find the output. 2 squared minus 4 times 2 plus 1, so that's going to be 4, minus 8 is negative 4, plus 1 is negative 3, and so my vertex is 2 comma negative 3, and then we can go ahead and put it right into vertex form. In this case, our a is 1, so y equals, or f of x equals 1 times x minus 2 squared x minus h. So x minus 2 squared minus 3, and that is my equation in vertex form. So go ahead and try the next one and then check your work. So checking your work, the second one I have f of x equals 2. Don't forget to put that a back into the equation that you already know, times x plus 2, because x minus negative 2 becomes plus 2, squared minus 1, and that's the same equation but in vertex form. And then on the right column, we're going to convert everything into standard form. So again, let's take a look at what that should look like. Everything should be multiplied out, no parentheses, ax squared plus bx plus c. Each term is in order from highest degree to lowest degree. And so to do that, we're going to simply multiply everything out. So just know that this is not the same as x squared minus 1 squared. We cannot distribute the exponent. We cannot distribute the exponent if there's a plus or minus in between. So f of x is just going to be equal to 2 times x minus 1 times x minus 1, in which case we have to FOIL, and then we'll distribute the 2. So that's going to give me x squared minus 1x, which is minus 2x, plus 1. And then distribute that 2. We've got 2x squared minus 4x plus 2 plus 1. And finally combine like terms. We've got 2x squared minus 4x plus 3. And that is my equation in standard form. So again, go ahead and pause the video and try the next one. Rewrite it into standard form. So I've got f of x equals negative x squared minus x minus 18. So that's how you convert between standard form and vertex form. Going to standard form, you're just multiplying everything out. And then going to vertex form, you just have to identify the vertex and put it into the equation. There is another way to change it from standard to vertex form by completing the square, which you might recall from last year, but I think this way is a little bit simpler and less to remember. Alright. And then the next part we're going to look at is focus on writing equations of quadratics, writing equations of parabolas given different information. So in example 1, we are going to create an equation, a quadratic equation in vertex form, given the vertex and a point. So let's start with what we want. We want an equation, quadratic equation in vertex form. So we have y equals a times x minus h squared plus k. Okay, that's what I want. And in order to get this equation, all I need to figure out is I need to figure out what a is, and I need to figure out what the vertex is. Now, the vertex, they already give me, it's negative 2, 5, so I can already plug that in, right? So y equals a times x minus negative 2, which is plus 2, squared plus 5. And now to figure out what that a is, remember x, y, these two variables, represent any points on my parabola. So if I want to figure out what a is, and a is a constant, that doesn't change regardless of which point I'm looking at in my parabola. So to figure out what a is, I'm just going to use this point 0, 9 that they give me. So I'm going to plug 0 in for x and 9 in for y and figure out what a is. So 9 is equal to a times 0 plus 2 squared plus 5. Simplifying, 0 plus 2 is 2, squared is 4. So I have really 4a, 9 equals 4a plus 5. Subtract 5, I have 4 equals 4a. Divide by 4, we have a equals 1. And so in our equation, a is equal to 1, and we are ready to write our equation. So our equation is y equals 1 times x plus 2 squared plus 5, and that is my equation in vertex form. Now, if I ask you to write it in standard form, all you have to do is multiply out x plus 2 times x plus 2 and then add 5. Right, and then moving on to page 4. Similar, example 2, but given different information. Create a quadratic equation in intercept form that has negative 2, 0 and 5, 0 as x-intercepts. So intercept form, remember, is the same as factored form. So it looks like y equals a times x minus p times x minus q, where p and q are the x-intercepts. And so it just says to create a quadratic equation in intercept form with these two as x-intercepts. So there's actually a lot of different answers that we can have for this. Y equals a times x minus, so since negative 2 is a x-intercept, x minus negative 2 would become x plus 2. X plus 2 would be a factor, and x minus 5 would be a factor, right? Which makes sense because if I look at this equation, to find the x-intercepts, I would make y 0, and then I would solve by setting each one of these equal to 0, and then I would get x equals negative 2 and x equals 5, which are my x-intercepts. So that's my equation. In this case, it doesn't give me enough information to figure out exactly what a is, and it doesn't seem to restrict a to any number. So it just says to create any quadratic equation with these x-intercepts. And so your answer could be y equals 1/2 times x plus 2 times x minus 5. Your equation could be y equals 3 times x plus 2 times x minus 5, etc. Alright, which means that you can have many, many parabolas that intersect at the point negative 2, 5. Some might be wider, some might be narrower, depending on where your vertex is. That doesn't matter. And so an a value of 1/2, that would give me a wider parabola, and an a value of 3 would give me a skinny and tall parabola because it's vertically stretched. And regardless of what you picked as your equation, go ahead and rewrite it into standard form. So for simplicity's sake in this problem, I'm just going to use the second one. Y equals 3 times x plus 2 times x minus 5. And to change it to standard form, again, we're just going to multiply everything else. So I'm going to multiply the x plus 2 times the x minus 5 first, and then multiply the 3 through. Technically, it doesn't matter whether you want to multiply these first or these two first because multiplication is commutative. But since it's pretty easy to distribute the 3, I'll do that last. So x squared minus 5x plus 2x minus 10. Simplifying, I have x squared minus 3x minus 10. And then distributing the 3, I have 3x squared minus 9x minus 30. And that's my equation in standard form. So whatever your equation is, you just gotta multiply it out. So now you are going to finish the rest of 2.1 practice on page 5. And everything, the notes and the practice is due by Wednesday.